you. Let's proceed to the fourth problem. I prepared 5 problems here. Let's go to the second to the last one. Problem number 4. If P equals 1 plus 3 plus 5 plus all the way until 83, and Q is equal to the sum of 6, 13, 20, all the way until 293, what is Q minus P? So we could see here that P is a sum of the odd natural numbers from 1 until 83, whereas Q is the sum of the terms of an arithmetic sequence with first term 6 and a common difference 7. How come common difference 7? So you see 6 plus 7, 13. 13 plus 7, 20, and so on, plus 7 plus 7 plus 7, until you reach 293. And if we subtract the values of Q and P, what is the result? So this time, it's time to divulge the answer or the solution to this problem. So from here, from this given, if we have Q minus P, so it's 6 plus 13 plus 20 all the way until 293, subtracted by the value of P, which is 1 plus 3 plus 5 all the way until 83 here. Now, the technique here is actually by making use of pairing them and making them into certain groups. So for example, I have here 6 minus 1, I pair them, and I let this be a group. So we have here 6 minus 1. The second one is 13 minus 3. Next one is 20 minus 5, and so on until 293 minus 83. And after grouping them in such a way like this, what we can do is we can simplify them per group. We could see that 6 minus 1 is 5, 13 minus 3 is 10, 20 minus 5 is 15, and 293 minus 83 is in fact 210. And from here, we could see that this becomes the sum of the positive multiples of 5 from 5 until 210. And using the similar technique we employed with item number 3 earlier, we knew that the GCF of each of the terms is 5. So factoring out 5, we have 5 divided by 5, 1, 10 divided by 5, 2, 15 divided by 5, we have 3, until 210 divided by 5, which is 42. Hence, we could say that Q minus P is equal to 5 times the sum of the first 42 natural numbers. And by employing the formula we have earlier, then we could see that this expression here inside the parentheses becomes 1/2 times 42, because that's our n, times n plus 1, or 43. And of course, we still have 5 here in front. We just copied it. From here, we could see that 42 divided by 2 is 21. So this expression is equal to 5 times 21 times 43. And multiplying all of this, we have a product of 4,515, which is the value of Q minus P. So I hope you got this item right. And if you did, congratulations. But if not, it's okay. What's important is we keep trying and we don't stop pursuing. And let's have our final problem for today. Find the exact value of 30 squared minus 29 squared plus 28 squared minus 27 squared plus all the way until 4 squared minus 3 squared plus 2 squared minus 1 squared. So if you could see, all of them are squares and they alternate in terms of signs. So we have here plus, minus, plus, minus, plus, minus, and so on. And maybe some of you have encountered this type of problems and probably in mathematics competitions. And in fact, believe me or not, this is an application of the sum of the first n natural numbers. And here's how. So if you could see here, the technique here is with the fact that we have to recognize a difference of two squares. Example, if we have this one, if we have the first pair, we have 30 squared minus 29 squared. We could see that this is in the form a squared minus b squared. And a squared minus b squared is factorable into a plus b times the quantity a minus b. Hence, if you have 30 squared minus 29 squared, with a equal to 30 and b equal to 29, for example, so this could be expressed as the sum of 30 and 29 times the difference of 30 and 29. That's why the 30 squared minus 29 squared is equal to 30 plus 29 times the quantity 30 minus 29. The same reasoning is used for the other pair. So 28 squared minus 27 squared is equal to 28 plus 27 times the quantity 28 minus 27, and so on until here, this becomes 4 plus 3 times the quantity 4 minus 3. And for the 2 squared minus 1 squared, we have 2 plus 1 times the quantity 2 minus 1. And if you could notice, I placed here in red color all the terms that have minus in the middle, minus in between them. We could see that 30 minus 29 is 1, 28 minus 27 is also 1, all the way until 4 minus 3, which is 1, 2 minus 1, which is also 1. In other words, all of the subtractions here will just result to 1. And when that happens, all that will be left will be 30 plus 29 here 28 plus 27, here 4 plus 3, and here 2 plus 1 will be left. That is why this complicated looking expression is equal to 30 plus 29 plus 28 plus 27 all the way until 4 plus 3 plus 2 plus 1. And if we rearrange the terms, we could see that 1 plus 2 plus 3 plus 4 is equal to 30. And note that this expression here is just equal to 1 plus 2 plus 3 plus 4 all the way until 30, because rearranging the terms in a series or in an addition sentence does not affect the result. And hence, this is the sum of the first 30 natural numbers. And with n equals 30, so this becomes 1/2 times 30 times 30 plus 1, or 31. 30 times 1/2, or 30 divided by 2 here, is 15. And 15 multiplied by 31 is equal to 465. Hence, this expression is equal to 465. So I hope you got them correctly. And before I end the discussion, let me quote Albert Einstein by saying that in the middle of every difficulty lies opportunity. An opportunity to learn something new, an opportunity to change, an opportunity to begin, and an opportunity to become better and better every day. With that, TYVM, thank you very much, and a great day to one and all. God bless everyone.